Well, hello, 8th graders. It's Mr. KV, and I'm back with another math tutorial, and this one focuses on this particular learning target. I can visualize, describe, and identify situations where percents are less than 1% or greater than 100%. So in class today, if we have time, we're going to take a little bit of time to do some mental math workouts and practice our multiplication, always helpful. From there, in today's learning, we're going to think back to our percents quizzes, those fun quizzes that we made some time ago, and we're going to try each other's quizzes and see if we can recognize, if we can estimate the correct percentages that you are able to find on your internet travels. And then from there, we're going to jump into our textbook. And so I want to work through a few of those problems with you today. All right, so understanding percent. They introduce the topic by talking about percents on the Earth. Let's take a quick look at those. 71% of Earth's surface is covered by water. 97.5% is salt water, and the remaining 2.5% is fresh water. About 70% of the fresh water is permanently frozen. Only about 0.007% of all water on Earth is fresh water that is accessible for humans to drink. That is remarkable. So that is quite a bit less than 1%. Let's move on a little bit. More examples there. I want to get to this section, get ready. So a few key ideas here. A reminder, percent means out of 100. Percent literally means part of the whole, part of 100. If we have a 10 by 10 grid here, if all of these cells, let's call them, or boxes, are shaded in, that gives us 100 out of 100. That is 100%. Here we have 53 squares shaded. That gives us 53%. And we'll talk, as we keep going, we'll talk about, if you have a 10 by 10 grid with 100 cells, how do you represent less than 1%? That gets a little trickier. First of all, though, try to estimate the percents of each grid. Now, you can count all of the little squares. I realize you can do that, but and maybe it's hard not to. But let's try to just estimate. And I want a pencil tool, so I'm going to go up here and zoom out and get my freehand. There, I have a red pen. And let's go back there. Okay, so what percent of each grid is shaded? So I'm going to say this is, about 15%. Okay, excuse my messy writing. And this is 64%. Yeah, it is hard to estimate without counting, for sure. We want to know, right? I'll say 46%, and this looks like 89%. Okay, really basic stuff. Explain how you could use a 100 grid to express each percent. So these are all within 1 and 100, so it really doesn't require a whole lot of calculation. Let's see if I can grab my, sorry for all the skimming back and forth here. Let's turn that to red text color. And so what I would write here is basically, I'm just going to choose, I went too far down. What I would write is shade in 3 cells. Here, okay. Gonna get weird on me, all right. Shade in 46 cells, and so on. I don't have to keep going, right? Okay, fractions, decimals, and percents. The diagram represents 3/4 because 3 out of 4 squares are shaded. You can show 3/4 as 75 over 100. That draws on what we learned in our last unit on proportions. Equivalent fractions, going back to the first unit. You can write 75 over 100 as a decimal, 0.75, and once we see this decimal, that also reminds us, that 0.75 is the same as 75%. Notice the little hack here: to change a decimal to a percent, multiply by 100% and add a percent symbol. Well, yes, technically that works, but again, anything you see, these first two spots after the decimal are always going to represent a percent out of 100. And so whatever is there, if we've got 0.01, that's going to equal 1%. Whoops. All right, we'll come back to that idea later. Show each diagram as a fraction, a decimal, and a percent. So I won't do all of these, but we have 4 cells here, so this is clearly 1 over 4. There's my fraction. A decimal, we have to do a little bit of mental math there, and there are different ways to do that. One way to do that is simply to divide 1 by 4. In your calculator, you can type 1 divided by 4, or I guess we can show the equivalent fraction here, 1 over 4. How do we get from 4 to 100? We multiply by 25, so we do the same up here, and that gives us 25. And then by a percent, show each diagram as a fraction, decimal, and percent. So of course, as we were just talking about, 0.25 is the same as 25%. So do that for all of these. And then draw a diagram to represent each number. So let's do this one here. 3/4, let's say we have a lovely square. I don't like it when my drawings disappear. Okay, thank you, DocHub. And those are perfect squares, right? Those are, they're not exactly perfect. But to, I don't know if there's a shading tool. Is there? No, I don't think so. Nope, I have to do the coloring myself. So what if we do this? Nope, too big, too big. I'll work with it. Okay, so we've got 1, 2, and 3 shaded in. That's some bad coloring, but you know what? You get the idea. 3 out of 4 shaded in. So again, we're starting really, really simply here. I know some of you are probably feeling a little impatient. You're ready to go on further. That's fine. You may skip ahead here if that is you. Show as repeating decimals. That's important. So we need to talk briefly about this idea of repeating decimals. A repeating decimal has 1 or more digits that repeat over and over without ending into infinity. So 2/3 equals 0.6 repeating. We can just put that line over it. A bar over the number shows the repeating part. If more than one number repeats, the bar extends over the repeating numbers until the pattern repeats. So in this case, you can't just put the bar over the 7 because the next number here is going to be a 1. So you've got to write the bar over the 1 and the 7. Show as repeating decimals. So based on what they just told us, what we just read, this would be 0.3 with a bar over the top of it. This would be 0.45 with a bar over the top of it. Both of those numbers. And wow, is that actually repeating? Yes. Okay, so 0.1327. This is a very unusual number, right? And we've got to put the number over, the bar over the 27. I have a terrible feeling like I'm saying lots of dumb things here. Show each fraction as a repeating decimal. So how can we find the values for these? So you can use a calculator. You can do some long division. Just for the sake of time, I'm going to use my calculator. Let's bring that into the picture here and say 9 divided by 11 equals 0.81 repeating. 0.81 repeating. DocHub is kind of driving me nuts here. We could try the same thing with 5 over 6. 5 divided by 6 equals 0.83 repeating. Now, careful with this one, right? Because in this case, it's not the 8 that repeats, it's just the 3. So we just want to put the bar over the 3. Now, why are we talking decimals all of a sudden? Because when we convert from fractions to percentages, in some cases, the fractions don't convert very nicely and neatly when we have these repeating percents. So we have to talk about how we handle that. Now we get into estimating percents. Place value is going to tell you the value of a digit in a number. To estimate the percent, you can use percents that you know. So 52% of 250, mentally you want to just round that over to 50%, and then you can say, okay, 50% of a number is half, so I know that's going to be 125. That's an easy estimation hack, let's say. 12% of 60, well, I know that 10% of 60 is 6. And then my mental hack would be, you know, if 10% is 6, then 1% is 0.6. We're going to move that decimal over 1. So I know that 12% would be 7.2. But yes, the key here is, you know, from 12%, go to a familiar percent that you are familiar with. Am I actually on morning supervision here? One moment. Let's pause the video. So what they want you to do here when we talk about the place value of the 5, what they actually want you to do is write out not just the tens place, they want you to write out 5 times 10. So for example, 5 in this case is in the tens place, as I said. So that 5 tens would equal 50, right? And then in this case, it is in the ones place, so it just equals 5. In this case, 5 is in the thousandths place, so I believe they want you to express it like this, 5 over 1,000, and so forth. Estimate each percent of a number. Okay, so for some reason I love estimation. It's just kind of fun for me. So use the rules that we talked about up here, kind of the rounding rules. So when we talk about estimating a percent, go over to, scratch that, 22% is close to 20%. 20% is to 10%. So I hope I'm not losing you there. But so let me show you my work over here. Take 85. I know that 10% of 85 is 8.5, right? We're just moving that decimal over 1. So 20%, if I'm estimating, is going to be twice this. And maybe a little bit more. So let's say 18. Now, I can't help but want to check my estimate. I know many of you are the same. So here's how we check it. 85 times 0.22. 18.7. I was so close. What a great estimate. Okay. 75% of 70. Why did my light go up? 75% of 70 is going to be, again, another mental way to do this is, I know it's going to be 3/4. 3/4 of 80 is 60. 3/4 of 70, let's say, is 55. That's my estimate. Show your thinking. Okay, I've got to show my thinking. So this is an old case of 70 over 1 times. Now again, we can follow different ways to solve this, but you know, you can write 210 over 4 and then divide that, and that's going to give you, wow. Okay, let's wait for those numbers to reappear. Okay, they're not coming back. All right, 210 over 4 equals 52.5. Is that 5 going to bounce back? Yes. If my mental math is correct. So 200 divided by 4 is 50. 10 divided by 4 is 2.5. So I believe that is correct. Okay. So we've finished the get ready section. And before I say goodbye, I also want to talk about some of these problems here. So 8.1, understanding large and small percents. They've given us, to start with, the problems of population, which is great because 7 billion is a really huge number. Let's talk about 7 billion for a moment. 0, 0, 0, that's 7,000. Add 3 more zeros, we're up to 7 million. And add 3 more zeros, we're up to 7 billion. Now, let's just, I love checking these things out on Google. So let's just check that out. Current world population, 7.594 billion. So it's actually a good, it's well on its way to 8 billion, which is incredible. But that's okay. We'll go with 7 billion. World population increases by 80 million people a year. That is 200,000 people a day, or 140 people every minute. What percent do you make up of all the people in your family, class, and school? So we're starting small. So in our class, we have 25 people, which is a great number. So you are 1 over 25. What percent is that? Well, actually, it's basically the easiest number possible because 25 turns into 100 very easily by multiplying, of course, by 4. So we do the same up here and we have 4 over 100 for an answer of 4%. Whoops, I did class first. In your family, let me back up to A. That's what I get for not reading the question carefully enough. I'll do my work here. Family, in my family, I am 1 of 4. And you probably know that 1 over 4, pardon me, is the same as 1/4. If you think of a quarter coin, we know that a quarter coin is 25 cents. That's common knowledge. That's where this comes from, a quarter of of 100 cents, right? So 25%. So that is my percentage. If you are in a family of 5 or 6 or 3, your percentages will be different. If you're in a family larger than 6, then I respect your parents greatly. What percent do you make up of all the people in your school? So I don't have an exact number of students at VCS, but for easy math, let's say 800. I think it's about 800. Okay, and put that in parentheses. That is not our final answer. So to calculate the percentage of, or what percent we make up out of the school, we're going to have to use our calculator here and divide 1 by 800. Now, here's where it gets interesting because finally we're going to have a percentage here that is smaller than 1%. Because, of course, if we were 1 out of 100, we would be 1%. But this is 1 out of 800. So estimate where you think this will end up. But here's the math. 1 divided by 800 is 0.00125. So this 0 right here is 1%. So this is going to be 0.1. Yes, 0.125. I want to make sure I'm saying that correctly. 0, because it's not even 1%, 0.125%. Now, notice what I did there. If this place value was occupied, by a 1, we would say 1%, no decimal, but it's not. It's actually, there's nothing in the tenths or the 100ths place. So that's why we're going to say 0% right here, and then start the decimal right here in terms of where the numbers begin. So that brings us to 0.125%. We'll do more of those practices as well. That's how to get started. I'm going to leave the introduction there for today. This was the first video. Let me know if this was helpful and how I can improve these going forward. I actually didn't get into too many of your assignment problems today, so maybe I can do a better job of that going forward. But if you watched this far, thank you for joining me. You are amazing, and best of luck as you continue to make your calculations and learn about percents greater than 100 and less than 1.